index, but now we can find a specific row by passing in that label. So if I say df.loc, this will be easier if we actually just look at an example here. If I say df.loc, before we were passing in a 0 as the label. But now I can say, okay, I want to see the information for Corey M. Schaefer at gmail.com. And then it'll come back and say, okay, that person has a first name of Corey, last name of Schaefer, and so on. So now we get the row for that specific email in specific columns as the second value. So I'll just say I want to have those default integers that we used before. So if I say if I want row of 0 using loc, then we're going to get a type error. If you want to use integer locs are available to you, and then it'll still give us that first row. We can do that with the reset index method. So down here, I will just say df.reset_index, and I will do an in place equal to true. So we can see that now we're back to having that email as a column and the default range index. Now, if you actually do that, let me of why using indexes is useful. Now, again, for those of you who have been following along with the series so far, this should look familiar to you. But if you haven't been following along, and this is the first video you've watched, here's a brief overview of what's going on. We are loading in pandas here. We are loading in some CSV files, using for these CSV columns to where we can see all the columns. Is what our data frame. Look at our data frame here. In the series so far, we've been using this default index 1, 2, and 3. Have a unique value per row within the data itself. So if we look at this respondent column here, respondent 1, respondent, is that respondent ID by coming down and then the data this index that here. So I'm going to say our index call back down here because now we have so if you loc, and let me delete that cell. Okay, so earlier in the series, another data frame. So let's min, and we can see that hobbyist wanted to locate data frame the index here where the column. So I will set up actually column. See that search for the hobbyist column schema of the okay. Hobbyist has the question text of do you code as a hobby? So let's go back to our survey data here and see if we can find a column that doesn't make, okay, like what would this one mean? MGR idiot, okay? MGR idiot. So let me scroll down here, and now I'll paste that in to the schemadf.loc and rerun that. Now we can see that we get the information for that column. Now, the text is actually truncated in Jupyter Notebooks by default, but we can change that setting if we'd like to see this entire question text. But I kind of want it on since we have so much data to display. But instead, if you want to see the full text for that question, then you can just access the data in that row and column directly by also passing in the column name into .loc as well. So just like we've seen before when we're using .loc, this is the row we want. So what column do we want? So we want to read that question text. So I'll paste that in. And now if I run this again, now we can see that the full question text for what MGR idiot means is how confident are you that your manager knows what they're doing? So this is one nice example here of when setting these indexes is useful because it allows us to make these search these rows by labels very easily, just like we did here with the schema. Now let me show you one more thing before we finish up here. So we can see that we were able to set our indexes and all of that looks good, but it might make it a bit easier to read this schema data frame if the indexes were sorted alphabetically. So to do that, it's just as easy as saying schema df dot sort underscore index, and let's run this. Let me scroll down here a little bit. And we can see that now these indexes are sorted alphabetically. So if we knew that we wanted to, get to employment.
No las había ejecutado.
or something, it's going to be in the E's. So that just makes it a little bit easier to find what you're looking for. And if you wanted to sort this in descending order instead, then we could just say ascending is equal to false. And now we can see that it is in reverse order here instead. So depending on your data, that might make it easier to read. So we're going to go over a lot more advanced sorting in a future video, but these are just some basics on getting our indexes in order. Now, as usual with our data frame, if you wanted to the sort to be permanent and carry over into future cells, then you should set in place equal to true. And we'll see that a lot throughout the series because doing it this way kind of allows us to see what things would look like without actually affecting the data frame itself. So down here, the data frame is still unsorted. But if I come up here and say sort index in place equal to true, rerun that, and then rerun our schema data frame, then now our schema data frame is permanently sorted. So depending on your data, learning about these indexes will be really useful, especially whenever you're using .loc, because it allows you to search by label there, which is extremely useful depending on what type of data you are searching through. Okay, so before we end here, I'd like to mention the sponsor of this video, and that is Brilliant.org. So in this series, we've been learning about pandas and how to analyze data in Python, and Brilliant would be an excellent way to supplement what you learn here with their hands-on courses. They have some excellent courses and lessons that do a deep dive on how to think about and analyze data correctly. For data analysis fundamentals, I would really recommend checking out their statistics course, which shows you how to analyze graphs and determine significance in the data. And I would also recommend their machine learning course, which takes data analysis to a new level, where you'll learn about the techniques being used that allow machines to make decisions where there's just too many variables for a human to consider. So to support my channel and learn more about Brilliant, you can go to brilliant.org/CMS to sign up for free. And also, the first 200 people that go to that link will get 20% off the annual premium subscription. And you can find that link in the description section below. Again, that's brilliant.org/CMS. Okay, so I think that is going to do it for this Pandas video. I hope you feel like you got a good idea for how to use indexes and why these might be useful. And like I said, you don't have to use indexes, but sometimes it just makes sense depending on your data. So for example, in this video, setting the schema data frame index made it very simple for us to look up column names easily. So in the next video, we're going to start learning how to filter data frames and grab data that meets specific criteria. So maybe we only want to see data where the salary is above a certain amount, or maybe we only want to see data for people who said that they use Python in this survey. So we'll take a look at being able to filter data frames on that type of criteria in the next video. But if anyone has any questions about what we covered here, then feel free to ask in the comment section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching. Hey there, how's it going everybody? In this video, we're going to go over the basics of filtering data from data frames and series objects. So for example, if we wanted to look at our survey data and only look at people who know Python, then we can filter that data out. Or maybe we only want to see results from a specific country or people that have a specific salary range, anything like that. We can do all of that by filtering out data from our series and data frame objects, and we'll learn how to do that in this video. So filtering is one of the main things to learn with Pandas because it's basically how we begin every project, by filtering the data that we want from the data that we don't. Now, I'd also like to mention that we do have a sponsor for this video, and that is Brilliant.org. So I'd really like to thank Brilliant for sponsoring this series, and it would be great if you all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. Okay, so first of all, let me show you something that's going to be the basis for our filters. If we perform some basic comparisons using our data frames, then we'll get back some interesting results. So let's see what this looks like. So right now I have my snippets notebook open that we've seen a couple of times throughout the series. And at the bottom here, I'm going to make a basic comparison and see what the result looks like. So let's say that I wanted everyone that has the last name of Doe from our data frame. There should be two since we have a Jane Doe and a John Doe here in our data frame. So in our bottom cell here, I'm going to put a comparison that says DF, and then we want to access that last name column. And now we can just say if that last name equals Doe. So if I run this, then what we get back is a series object. And this might not be what you expected. So maybe you thought we would just get a data frame back with all of the values that met our criteria. But what we got back is a series with a bunch of true-false values. Now, these true-false values actually correspond to our original data frame. And the true values are the rows that met our filter criteria, and the false values are the rows that didn't meet our filter criteria. So you can basically think of this like a mask. So we can see here up here in our simple data frame, the last name of Schaefer is false, and these two last names here with Doe are true. So this is a filter mask and when you apply it to a data frame, it will give you all of the rows that meet that filter criteria. So now let's
Estoy bastante cansado. ¿Cuánto va el streaming? No me dice. 13 minutos. Mm, pues no hay nadie aquí. Si avanzamos algo. Tratemos de seguir avanzando.
apply this filter to our data frame.
Hasta que se acabe
So
este
first,
video.
I'm going to assign this, this returned series here to a variable. And I'm just going to call this variable filt. So I'll say filt is equal to, and then this comparison here. Now, filter is a built-in Python keyword, so be sure to use something else. Anytime I assign these to variables, I usually just use this filt keyword here, or not keyword, but variable name. Now, I also usually like to wrap my entire filter in parentheses because I find it easier to read. So this isn't going to change anything, but I'm just going to put this entire thing here within parentheses so that I can see that this assignment here is separate from this equal sign. Okay, so now we have this filter here. And remember that this filt variable here is equal to this series here of true and false values. And now let's apply this filter to our data frame. And we can do this in a couple of ways. So you might see some people do it like this. We can just pass that directly in, like we are searching for a column. We can pass in a filter there. And if I run this, oops, and I got an error there because I did not run this cell to set that variable. So I'll rerun that. And now if I run this, then now we can see that we get a data frame back where it returned all of the rows that have the last name of Doe. Now, we only assigned the filter on a different line because I think that's easier to read, but you might see some people put these comparisons directly in the brackets for the data frame. So you might see something like this. So I'm just going to comment that out right now and just grab this entire filter here. You might see some people do it like this and just paste it or put it directly in there. And we can see that that works too. Now, I think that that's a little more difficult to read than just assigning this to a variable. So I'm just going to use that as a variable, but you should know that it is a possibility since you will see some people put the filter directly in there. Okay, so that's one way of narrowing down those rows. Now, another way that you can do this, and the way that I prefer to do it, is to use the .loc indexer that we've seen a few times now. And I'll talk a bit about why I prefer this in a second, but if we pass in that series of booleans into .loc, then it should give us the same results that we currently have. So if I say df.loc and pass in that same filter, then we can see that we get the exact same thing. This here gave us the same results as our .loc down here. So this is one reason why pandas can be a bit confusing to people, because there are multiple things that you can pass into these different brackets to get different results. So like I said before, .loc is used to look up rows and columns by label, but if you pass in a series of booleans like we did here, then you can also filter data out. Now, the reason that I like using .loc for this is because we can still grab the specific columns that we want as well. So for example, if I wanted the email column, then I could simply say, pass in a second value here into .loc and just say that we want that email column. If I run that, then we can see that we get the emails that match those last names. So remember, the first value to .loc are the rows that we want.
¿Qué le pasa a esto?
And the second value here are the columns that we want. So since I wanted the email column, it gives me a series of those emails where the last name is equal to Doe. Okay, so real quick, let's go over some other ways to filter data out here. So first, let's go over the and or operators. Now, we can't use the Python built-in and or keywords for our filters, so we're going to be using some other symbols. And the symbols that we're going to use here are the ampersand for and. Let me write these out here. The ampersand for an and this vertical bar for an or. So these symbols carry over from other programming conventions, so you may have seen them before. So for example, let's say that we wanted our filter to get all of the rows where the last name is Doe and the first name is John, which should only return this one result. So in order to do this, we can go back up to our filter here, and I'm just going to get rid of this cell here because I'm just going to be using .loc from now on. So now with our filter here, let's say that we want a last name equal to Doe, and, which we're going to use the ampersand, and we want the first name equal to John. So I will put that in here. And I also, let me actually separate these out as well. I like to have each one wrapped in parentheses. I think it makes it a bit easier to read. So now if I rerun that filter and then rerun our .loc, then we can see that now we're just getting that single email address. And that email, again, is where all of the last names were equal to Doe and the first names were equal to John. So in this case, it's just one result. So now let's look at an example using the or operator. Now for this, we can use the vertical bar character. So let's say that I wanted a filter where the last name is equal to Schaefer or the first name is equal to John. Okay, so if I wanted the last name to be equal to Schaefer or the first name is equal to John, for the or, we're going to do a vertical bar character there. So now if I rerun this, then we can see that we get back all of the rows or all the email addresses where the last name is equal to Schaefer or the first name is equal to John. So in this case, it was these two rows here. Now we can also get the opposite of a filter. So let's say that I wanted to get the complete opposite of this filter where we want all of the rows where the last name isn't Schaefer and the first name isn't John. Now I could go in here and fiddle around with this query that I currently have, trying to get everything right, or I could simply add in a tilde at the beginning of this filter, and it will give me everything that didn't match that filter. So if I just come in here and put a tilde there, then that is going to negate that filter and give me the opposite of those results. So we can see here that we get Jane Doe because that is all the results where the last name was not Schaefer or the first name wasn't John. So this goes back to truth tables that some of us may have studied in school. Now, if anyone is unfamiliar with truth tables, then let me know and maybe I can make a future video on that subject, but it's more mathematical related than programming related, although the two do overlap very frequently. Okay, so that kind of covers the basics of filtering on a small data frame. But now let's go back to our larger data set of survey data and look at some real world examples of some filters that we might want to take a look at. So I'm going to bring up my other notebook here. And here we have the Stack Overflow survey data that we've been using throughout the series. And again, if you'd like to follow along, then you can find a link to this code and the data in the description section below. Okay, so now that we've learned about some basic filtering, let's see if we can run some filters on our survey data here. So for example, let's say that we wanted to look at the data for people who are making a salary over a certain amount. Now maybe we want to take a look at what languages are earning the higher salaries or something like that. So in order to do that, I'm going to first create a filter. Now, if you don't know which column in the data frame gives the salary, then you can always find that using the schema data frame that we've seen throughout the series that tells us what each of these columns here means. But for the sake of time here, I'll just tell you that the column for salary, if I go over here, I think I can find it here pretty quick. It is this converted comp right here. So if we scroll down through some of these survey results, we can see that this person says that they make about 9,000. This person makes 61,000, and these are converted to USD. And real quick, let me reload this page here just to make sure that I have run all of these cells and that I'm that all of these variables here have been initialized. Okay, so if we wanted to get a filter with all of the high salaries, then let me come over here and again, I will copy this column name here. And now let's make a filter. And I'll call this filter high salary. And I'll set this equal to a conditional here where we're saying that we want the DF of this converted comp column of our data frame. We want that to be over, let's say a high salary is over 70,000. You know, this is kind of subjective, but we'll do that as a filter here. And now let's apply that filter to our data frame. So just like we saw before, I can say df.loc and I can pass in that high salary filter there. And now we can see that we get some results here. And this isn't all of our respondents. We can see that now it's respondent 6 and 9 and 13. So if I scroll over to our converted comp, then all of these salaries here should be over 70,000, and it looks like they are. Now, in order to narrow these columns down a bit, let's just grab a certain number of columns. So I'll grab the country, the programming languages, and the salary. So to do this, remember we can just pass these into .loc. So up here where we're doing .loc, I'll put in a comma here, and now I'll put in a list for the columns that we want. And let's say that we want to get the country. We also want to get the programming languages that these people have worked with. And this here, and like I said, you can look all of these up in.
No, yo creo que ya es suficiente. Bueno, eso es todo por hoy. Tengan un día genial. Si les gustó el contenido, déjenme un like, compartan, suscríbanse, vean todo lo que promuevo debajo en la descripción. Y perdón por no ponerle los subtítulos. Si tuviera un chat, pues me acordarían. Si estuvieran en el chat, ustedes. Bueno, hasta luego, tengan un día genial.